Okay, what we have been doing in the previous few videos is looking at the current in this RL circuit when we apply a cos voltage to the circuit, right? Now, as we were talking about in the last video, this Vm cos omega t is the real part of Vm e to the power j omega t, right? And if you evaluate the output when the input Vm e to the power j omega t is given, and you evaluate the current and take the real part of that current, that's going to be the solution of the current here. Okay, so basically let's look at this circuit, look at the solution to this circuit. Okay, when the voltage source is Vm e to the power j omega t. Okay, and the differential equations remain the same as before, right? L di by dt plus IR will be equal to the Vm e to the power j omega t. So that's our differential equation. And the solution to this differential equation is simply going to be I of t is going to be of a different amplitude, and it will have a different phase but the same frequency, right? Some signal like this. So let's substitute this solution into this differential equation and see how where we get. Okay, so let's write L di by that's d over dt I am e to the power j omega t plus phi plus I am r e to the power j omega t plus phi equal to Vm e to the power j omega t. And that's going to turn out to be L. And how would you differentiate this? You would get omega Im, and then you get a j as well, and you have e to the power j omega t plus phi plus Im r e to the power j omega t plus phi, and that's equal to Vm e to the power j omega t. Okay, you could cancel the e to the power j omega t terms from both sides, and what you get is j omega L Im e to the power j phi plus Im r e to the power j phi equal to Vm. Okay, and that and from here we should be able to calculate Im and phi. How are we going to do that? You can write this as Im r plus j omega L e to the power j phi equal to Vm. Okay, and this equation becomes Im. What's the magnitude of this complex number? It is r square plus omega L square whole square. And what's the phase of that? That's the phase of that is going to be tan inverse omega L by r, and therefore you can write this as e to the power j tan inverse omega L over r, e to the power j theta equal to Vm. Now if the left hand side and the right hand side are equal, then we know that this term, this magnitude term, should be equal to Vm, and this term theta tan inverse omega L over r should be equal to 0. Theta plus tan inverse omega L by r should be equal to 0. So I've just written this equation on the other page, and if you solve it, what we are saying is Im should be equal to Vm over square root of r square plus omega L square, and your theta should be equal to minus tan inverse omega L over R. And you can check that this is the same solution that we got in the previous case, right? But you can see that this method is slightly more easy than the previous method. So we have made progress, but perhaps we can go a little bit further, and we'll do that in the next few videos. Now, once we have this current that we set, right? So our output current was e to the power j omega t plus theta. And if we get we know the values of Im and theta now. So if we take the real part of this, that's going to give us Im cos omega t plus theta. And therefore, that is going to be the output of the circuit when the input is Vm cos omega t.